Assalamu alaikum. In the previous video, we obtained the expression for kinematic equations of linear motion. In this video, we will derive kinematic equations of circular motion. Before going ahead, let me tell you what is the circular motion. Whenever an object moves in a circular path, then it is said to be in circular motion. Remember this? Now suppose I have a circular path in which an object moves, then this object is said to be in circular motion. Okay, let's see. This object possesses the initial velocity omega naught. So omega naught is actually initial angular velocity. No? The velocity possessed by an object in circular motion is referred as angular velocity. It represents the letter omega. After time t, the velocity, angular velocity of this object is found to be omega. Right? So here there is a change in the angular velocity of this object. We know whenever the velocity of an object changes with time, then the object is said to possess acceleration. That means object is getting accelerated. So here the variation in the angular velocity with time is referred as angular acceleration, represented by letter alpha. This represents angular acceleration, which is nothing but rate of change of angular velocity. Change in angular velocity with the time. Yeah. Now I have these terms: acceleration, time, initial velocity, and the final velocity. Now with these things, I am going to get the kinematic equations of circular motion. One thing is missing here is nothing but displacement. In time t, the object moves to certain distance. It covers certain displacement called as angular displacement. Change in position of the object in a given time is referred as angular displacement, represented by letter theta. It is nothing but the angle subtended by the object when it moves along the circular path. Okay, suppose this is the center of the circular path. Now I connect this to the object under motion. Suppose after some time the object has moved to this point, then the angle suspended, angle traced by the object is nothing but angular displacement. It is represented by letter theta. Got it? Now before writing kinematic equations of circular motion, I am going to mention kinematic equations of linear motion. Kinematic equations of linear motion. Then this side I'll represent kinematic equations of circular motion. Let's do it. The first kinematic equation of linear motion is nothing but v equals to u plus at. It relates the velocity and time. And the second equation of motion is s equals to ut plus half at square. This relates the displacement and time. Third one is nothing but v square equals to u square plus at. Fine. So these are all these three represents kinematic equations of linear motion. Now, to get the kinematic equation of circular motion, we replace certain parameters present in this equation with its analogy. What are they? In linear motion, we have initial velocity, which is replaced with the angular initial velocity, which is omega naught, whereas the final linear velocity is replaced with the final angular velocity, that is omega. Then in both the cases, time remains same. Alright. Then here linear acceleration is replaced with the angular acceleration in the kinematic equation of circular motion. Then after that, S stands for displacement in the kinematic equation of linear motion, whereas in the kinematic equation of circular motion we use the angular displacement represented theta. Now, by using these terms in the place of this term, we are going to get the kinematic equations of circular motion. Let's do it. See? In the place of v, I write omega. In the place of u, I have to write omega naught. In the place of a, I write alpha. In the place of t, this is mentioned as such. Next, I'll get a second equation of motion. In the place of s, I write a theta. In the place of u, I write omega naught. In the place of t, is kept as such, plus half. In the place of a, I write alpha. From here. In the place of t square, is kept as such. Then third kinematic equation of circular motion is obtained by replacing these parameters according to their analogy. Okay, what are they? In the place of v, I write omega. In the place of u, I write omega naught. Square it. Then in the place of e, I write alpha. In the place of t, is kept as such. So these three represents kinematic equations of circular motion. I hope the video is useful. If you have any kind of doubt related to the topic, kindly put your questions in the comment section. Thanks for watching.